In this lesson, we are going to find the time period of a spring block system by the energy method. So this is a block of mass m. This is a spring of spring constant k. At this position, the spring is in its natural length. Therefore, the force on the block is 0. So this becomes the stable equilibrium position or the mean position. Now, at a displaced position, this block is having some velocity v. So this position is not the extreme position. So at this position, the block is having a velocity v. The spring also is extended. Therefore, there is some potential energy stored in the spring. Therefore, the total energy, which will be sum of kinetic energy plus potential energy, will be equal to half mv square plus half kx square. Half mv square is the kinetic energy of the block and half kx square is the energy stored in the spring. All this is at that displaced position. Total energy in SHM is constant. Therefore, this will be constant. If you differentiate this equation with respect to time, we will get 0. So d by dt will be 0. Now if you differentiate this, half m is a constant. If you differentiate v square with respect to v, we get 2v. But we are differentiating with respect to time, so you will get dv by dt. Plus half k again is a constant. If we differentiate x square with respect to x, we get 2x. But we are differentiating with respect to time, so to multiply by dx by dt. And this will be equal to 0 because differentiation of a constant is 0. So now 2 will cancel 2, 2 will cancel 2. This will give us mass into velocity into acceleration because dv by dt is a, plus kx dx by dt is v. So this will be equal to 0. So therefore we get mva equal to minus kxv. So v cancels from both sides and a becomes minus k by mx. And in SHM, acceleration is minus omega square x. So omega becomes root over k by m. Time period is 2 pi by omega. Therefore it is 2 pi root over m by k. So this is how we get the time period of a simple pendulum by energy method.